Did we start this one? Part A? I know. Okay. How do we know if we're moving up or down?
If the velocity is positive.
Good. So I need V of 1.5. This is a calculator question. So I'm going to type that in my calculator. Make sure your calculator is in radians, as always. What did we get? What is the number?
1.167.
Okay, this does say why, which is like a justify question. A lot of people think that means I need to write a book. Did I justify? Yes, velocity is this number, which is greater than 0, therefore up. Now, it's okay if you write a sentence, but you don't have to. It needs to be a complete thought. It doesn't have to be English sentences. It can be math sentences. Find the acceleration at 1.5. Of course, we can do that derivative by hand. You better be able to do that derivative by hand, but you can tell this is a calculator problem. Can your calculator do that derivative at 1.5 for you?
Do you have to show your work?
Nope. Here's what I would show for work.
Negative 2.049.
Don't put a naked answer, an answer without a label on it. Let the reader know how you found it. Doesn't mean you have to show any work, because if it's a calculator problem, they're going to know you use the calculator. But make sure you say, hey, I found this by doing V prime. Other than that, that's all you need to do. Is the velocity increasing or decreasing at 1.5?
It's decreasing.
Decreasing. Why?
A of 1.5.
Acceleration and velocity is different.
Which you could have put less than 0 up here, and that would have been okay as well. Given that y of t is the position, and that, yes?
When you put it in your calculator, do you put this x squared? Do you put it inside the parentheses?
Yes. Yes, but on the sign.
Yeah.
The time that you do this squared is when it's sine squared of t. Given that y of t is the position, y of 0 is 3, find y of 2. How would I do that?
The position is the x-axis.
Good. So we're going back to position. We have velocity. Antiderivative. Now, it is doable by hand. This is a calculator problem, but it was a really old calculator problem where calculators didn't do integrals yet. You could type in a few things in the calculator, but it was a little different than a modern day. It is anti-differentiable by hand because of I can do a U substitution, get the 2t outside. I'm going to show you that. If this is on a modern day calculator problem, though, you can do this completely in the calculator. Agreed? You would type, I want to find y of 2. So what would y of 2 be?
Integral from 0 to 2.
Plus
T.
V of t plus 2, or plus y of 0. Why do I add y of 0?
Ending point.
Good. Start point equals ending point plus the integral, or if you subtracted this y of 0 over, you have the fundamental theorem. However you want to memorize it, it's up to you. You do need to know that, though. So remember, the integral gives you the accumulation of distance. But if you want position, you have to know where you started. So I could have the same velocity as someone else who started behind me, but I'm still going to be ahead of them position-wise. That makes sense. So that's kind of like your head start, but wherever your head start is. You can type this in the calculator. Y of 0 was 3, so you can type all of that in the calculator, and that's wonderful. Does anyone want to see me do that antiderivative just for practice for the mastery exam? Okay. So the integral, what was it, t sine of t squared? I'm going to let u be t squared. Du would then be 2t dt. And I am going from 0 to 2. I'm going to go ahead and put that on here too. So I get 1 over 2t du is dt. I'm going to change my endpoints. Instead of being 0 and 2, they're going to be still 0, because 0 times anything, right? And then it would be 2 sine of 4. Everyone agree with that?
Wait, why wouldn't you plug in the U?
Oh, I would. Sorry, my bad. Sorry. 0 to 4. Sounds much better. Thanks. Glad y'all are taking care of me.
It's because you're pregnant.
Yeah, we'll call it that.
Yesterday.
She was still pregnant yesterday.
Yeah. I'm glad y'all think I can blame all my mistakes on that.
I would.
Yeah, I'm pregnant.
The t's cancel. And that is a u now in there.
Are you still pregnant?
I hope so.
Good. Lie on that.
Okay, the t's cancel. And so now I'm left with 1/2 integral from 0 to 4 of sine of u du, which is 1/2 sine of 4 minus sine of 0, which is 0. Does everyone agree with that? It would be cosine. I think I just need a nap. I don't think that has any negative. It would be negative cosine. Glad y'all are on top of things. Minus, and that would not be 0, because cosine of 0. Why don't we actually do an antiderivative and write that down? There we go. Cosine of 0 is 1, and so we would get minus 1. That look right? Finally. Okay. Again, this was calculator.
Be plus 1.
No, I don't, yeah. Because minus negative. Yeah, it would. It was rough. And then we would add 3 to that, correct?
Yes.
Again, this was a calculator problem. You would not do this by hand, but on other things, you would have to do things like that by hand. So, just for practice, what is the decimal value of that? And this problem didn't give us any units, did it? If it did, that would be a distance unit, like feet, meters, miles, something like that. Part D, find the total distance traveled. And you can really tell that this is a calculator problem, probably. Total distance traveled would be the integral. Where are we going from and to?
0.
Absolute value of t sine of t squared dt. And you can type that in the calculator. If you were going to do that problem by hand, you would have to find when sine of t squared equaled 0, and you'd have to integrate from there to there, and so you'd have to break it up. Again, this is a calculator problem, so we're going to type it in the calculator.
I thought the total distance was going to be velocity. I thought we had to change it.
The integral of the absolute value of velocity. Now, if you have a calculator, you can literally just type that in. If you don't have a calculator, the absolute value by hand is a little tricky. You have to do the integral in pieces.
Yeah, that's what we did for number 1
Mhm.
the other day, but we used a bit different equation once we got down to it.
The antiderivative?
Yeah, that's what that is.
Yeah. Because you'd have to, if you were going to do this by hand, you'd have to do the antiderivative. Because how do you do an integral?
It's the same equation we started off with, but we just went down to the
Which one?
on 1b.
Oh, are you talking about because we distributed it out? Is that what's... Or are you talking about because we did the antiderivative? Anytime we have an integral symbol, if you're going to do that by hand, it involves... Yes, it takes care of all of it for you in the calculator. Calculators are amazing.
Mm-hmm.
What do we get?
1.13.
And again, that's some units. I don't know what kind of units, but feet, meters, miles, who knows. Okay. One more. And then we will have some work time. A squirrel starts at building A at time 0 and travels along a straight wire connected to building B from 0 to 18. This is the squirrel's velocity. Remember to always pay attention to what graph they give you. And it says it's a piecewise linear function. This is velocity. Yep. Graph of V. Which, if you didn't know that, it says it in the problem. At what times in the interval 0 to 18, if any, does the squirrel change direction? Give a reason. What are you looking for if we're looking for a direction change on a velocity graph? When it crosses the x-axis, right?
Does starting from nothing and going positive, does that count? Since you're not doing anything.
I wouldn't count it. I don't know that AP would count it off, though, if you did put it. They'd probably give it to you, but I wouldn't put it. Am I finished? And what's my reason? Is being zeros enough?
They're changing
Changes what? Signs. Why is just having a 0 not enough? Right, it could just could touch 0 and bounce back up. You didn't change directions. You might have just stopped and tied your shoe. I don't know what you did.
Squirrel tied his shoe.
Yeah. There, that's it. That's a better one. Okay, part B. At what time in the interval 0 to 18 is the squirrel farthest away from building A? So this is, the squirrel starts at building A, right? And then he goes away from building A? back toward building A, and away from building A, right? Make sense? So what are our possibilities? What are our candidates? 9
15. Oh, 18.
and 18. Now, if you said 15, you wouldn't be wrong. You could count it. Why did we skip 15? It's a relative minimum, isn't it? Because I'm changing from negative to positive. So it's a place where I could be closest to building A, although I'm probably closest to building A when I'm at building A. So I'm finding the maximum.
If you do like difference area kind of thing,
Mm-hmm.
you can find area of that.
In fact, that's what I'm going to do. On part B, I'm going to find the position. I'm going to call it S. They didn't call it anything, did they? At time.
They're calling X.
Oh, okay, we'll call it X. That sounds good to me. If you called it S instead of X, they will not count. You're wrong. The presenter that I had last summer said, because a lot of people always ask that, will they count off for, and he calls them spelling errors, and he says we don't count off for spelling errors in calculus. He was an AP reader. So I'm going to find the position at 9 and the position at 18. If you had gone ahead and found the position at 0 and 14 or 0 and 15 as well, they would think that was wonderful. It's okay that you don't find those, but they wouldn't count off if you did. That would just be a really thorough candidates test. Position at 9, wouldn't that be this accumulated area here? Because to go from velocity to distance, you would do area. So I'm going to do the area of that trapezoid, which is 1/2. Let's see, the bottom is 9 units, the top is 5 units, and then it's 20 units tall. 20 times 5 plus 9. Let me stall on that. Does anyone not know what I'm doing there? We all okay? 14 divided by 2 is 7. 7 times 20 is 140. So 140 units. Do we have units? Still no units. And 18, 140 minus this trapezoid. Did you say why?
Yeah, Katie answered it.
Awesome. Good job, Katie.
Why?
Because this distance, he's going backwards, back toward building A. So I'm going to subtract the distance from where he went back toward building A. And then I'm going to add that last piece. So what I'm really finding, if you had put x of 15 is just subtracting that second trapezoid. I'm going to do more than that. There's a height on that 10. And the base is 4 and 6. Is that right? And then I'm going to add the last piece, which is another trapezoid. Height of 10. Is that right? Base of 3 and 2.
Do you have to show like actual trapezoid
Nope.
method? Like you just like you do all the math in your head?
Yep. You can. The one danger in that is doing the math wrong, and then you have no work. But no, we can look at the point totals and see where but they would never count off for you doing that. And you could use triangles and rectangles. You don't even have to use trapezoid. You can do whatever you want to find that area.
Being a calculator question.
Yes. 10 divided by 2 is 5. 5 times 10 is 50. So this is 140 minus 50 plus 25. Now, even though you don't have to work it all out, you have to work it out enough to know that that's less than 140. Right? That's really all you need to know. So, what was the question? At what time is the squirrel farthest from building A? At time t equals 9, the squirrel is farthest from building A. Second question, how far is he from building A? He is 140 units. And I would say on this one, I probably wrote more than I had to. But
go back and circle 140. Or just say,
at
the bottom, just say X9.
You could up here at the 140, maybe say 140 units. I don't know. I'd make a conclusion. I don't know. I'd be careful about that. Now, I did write a little more than you would have had to on there.
It just says how far I have to do to say that the X9 equals 140.
Yeah. Just make sure that you actually state it somewhere. 140 units away at t equals 9 or something like that. C. Oh, and notice it didn't say justify, but if it did, all I'd have to say is back in its test. Find the total distance. I would argue I've done a lot of that work already. Would you agree?
Mm-hmm.
How are we going to do total distance?
Isn't that the 18 plus 50?
Okay, right here, instead of subtracting 50, I'm going to add 50. Right? Total distance traveled by the squirrel. He went forward 140 meters, backwards 50 meters, and forwards 25 meters. And yes, if this is non-calculator, if you leave it like that, they will give it to you. I'm going to go ahead and add it. But
wait, so if it is a calculator, they would give it to you?
Well, they would on calculator too. They'd probably roll their eyes a little more on calculator, but they'd give it to you.
And you just run it at a time?
Yeah.
Or you just don't want to risk the chance of typing something wrong with the calculator.
And what do we get? Write expressions for the squirrel's acceleration, velocity, and distance that are valid from 7 to 10. So I only need the velocity from 7 to 10. I could have done, they could have made me do all of them, but they're only making me do the velocity from 7 to 10. That is what I read, right? Velocity, position, and acceleration from 7 to 10. I don't know, was that was probably just...
The A one is just the slope.
Good, the A one's just a slope, I like that. I like starting there even. That's what my brain would do. Find the slope, isn't that the easiest thing to find?
Yeah.
Rise over run, y2 minus y1 over x2 minus x1. However you feel like doing that. What are we going? 10, 30 over what? 3? So 10?
Negative.
Negative. Velocity. Well, we know the slope. We just need to find the y-intercept, right? Two ways you can do that. You could solve for b, or you can do y minus 20 equals negative 10 times x minus 7.
We can use either point.
Yes, you can use either point. When you add over, it'll come out the same. Negative 10x plus 70 plus 20, so plus 90. I should check my math. I don't have a very good track record
What are
today.
you doing right now? You're just
Find the equation of that line.
Why can't you just take the antiderivative?
Yeah, that's fine.
Okay, plus c and then find c. Sure. If you want to. If you think that's easier than finding an equation of a line, sure. Man, you're in an interesting place in your life when calculus is easier than algebra 1. But yeah, well, that would be plus 70, right? And then plus 20
So negative 10x.
plus 90. That's what I'm getting. But I'm waiting on y'all to check because I have a pretty rough track record today.
does it matter?
It does not matter which point you use. I use the first one, but they will give you the exact same answer when you add over. Now, on that one, I could have anti-differentiated, or I could have... Yes, that's right.
Like, how would you find that if you did?
You'd have to use a point, like the point 720, and plug it in for x and, or for t and v of t. Like you plug 20 in for v of t, you'd solve for c, which would give you 90, it'd be the same.
Did you use 10 as y1 or as x1 instead of 7?
The second point. For s of t, would you agree I have to use an antiderivative? Now, this one I could use because there's a line sitting there, I could find the equation of the line. For s of t, I am going to have to use an antiderivative. And I know at time 0, I'm at position 0, right? So I have an initial condition for position.
You just set up and leave it.
No. So the antiderivative, side note, is x squared divided by 2, so negative 5x squared plus 90x plus c. But if at time 0 my position is 0, what is c? 0. But I do have to think about it. Even though I'm not doing anything there, it's because I started at the building. I think that's all. Questions about that one?
Just because C is given, no, you can leave it in the journal.
Definite. Yeah, C is given, and it actually wants an equation for position. So.
Why did C cancel out?
It didn't cancel, but at time 0, the position is 0.
Do we always have this whole graph was moved up? When it always goes, it was at 10. It'd be 10.
Or any point they give you, any initial condition. Say that again, Kelsey.
So this whole graph was moved up, and at 0 was 10. It would be 10.
Mm-hmm.
Is that like you
Right. So if they said the squirrel starts 10 units from building A, right? It starts 10 meters away from building A, then this would be a plus 10 after this.
Why don't we do 7?
Is that a point on the position function? What point is that? The 720. What point is that on? It's on the velocity function. Okay, same homework, nothing's different. At work, you can also ask me test questions as well in the next few minutes. You have a little bit of time, so ask me some questions.
I have a question about the instant goal.
Sure.